tangga ke angkasa. Bukan mudah mengubah mimpi jadi reality.
Assalamualaikum and hi everyone. Selamat datang ke channel Madam Fika Fiki. Kali ini pelajar semua akan bersama-sama saya dalam sesi Revision with me bagi Subtopic 2.1 iaitu Kinematics of Linear Motion Graph dari Chapter 2. Jadi, siapa rajin? Jom kita mula.
Okay, now we are going to discuss about the physical meanings of kinematics linear graph. The first one is displacement time graph. Second is velocity time graph. And the last one is acceleration time graph. So, based on these three types of graph, we're going to discuss what is the meaning, what is the physical meaning. Okay, that's showing by the graph. Okay, so now we have three types of graph. The first one is ST graph, second is VT graph, and the third one is AT graph. As we know, okay, for graph S against T, the gradient of the graph, okay, so the gradient of the graph S against T will give you the value of the velocity. Okay, so for the graph V against T, the gradient of the graph will give you the value of the acceleration. Okay, so now let's look at the motion of the graph. Okay, let's say here is 10. Okay, so let's say here is 10 meter. So let's say the unit is in meter, okay, and time is in seconds. So what we can say about this motion, so let's say this one is 5 seconds. Okay, you can see that the pattern of the graph, okay, horizontal straight line graph. Okay, the pattern of the graph is the horizontal straight line graph, means that the object is not moving. The object is static. Okay, object tidak bergerak, static, at rest, stationary. So in 5 seconds, okay, the object is static. Okay, and when we try to calculate the gradient, so no gradient here, so the gradient here is 0. Okay, so since the gradient is equal to 0, means that in that 5 seconds, okay, selama 5 saat tadi, what happened to the velocity? The velocity is 0. It's not moving. Okay, and the gradient here also equal to 0. Okay, so means that the acceleration is equal to 0 meter per second. Okay, so this is the meaning of this tree graph. Okay, now let's move to the next one. Okay, how about this one? Okay, look at here. Okay, let's put a number. Kita letak nombor kat sini. Meter second. From 0 to, let's say, to 5 second. Okay, kita boleh nampak from 0 to 5 second. Okay, the displacement of the object is increasing from 0, 1, 2, 3, 4, 5, 6. Contohnya kan. So 6 meter. So in 5 seconds, it's moving to the right from 0 to 6 meter. Okay, in 5 seconds. So object is moving in positive direction. So let's say we take it as to the right. Okay, dia berjalan ke depan. Okay, so now let's look at to the gradient of the graph. So when we try to calculate the gradient, so let's say here at 1 second. So at point here, let's say the point here is 3 seconds. So what is the gradient? Okay, you can see here the gradient of the graph at 3 seconds and 1 second is the same. Okay, so bila kita kira kecerunan graf ini, okay, kecerunan graf ini, okay, memberi kita nilai velocity. Okay, velocity. So, in 5 second, maknanya objek tu bergerak ke hadapan, ke kanan. Okay, in positive direction. Okay, and at any point, since this is a straight line graph, means that the gradient is constant. Kat mana-mana point pun, gradient dia sama. The gradient is constant. Okay, means that the velocity is constant. So, how to calculate the velocity? We need to calculate the gradient. V is equal to, kita kira lah, y2 minus y1. Okay, 6 minus 0 over 5 minus 0, for example. Okay, so kita pun kira. Alright, so we calculate 6 divide 5, 1.2. Okay, so after the calculation, okay, the value of the velocity in 5 seconds is constant. Okay, dia tidak memecut. Okay, dia bergerak dengan constant velocity. Okay, laju yang so this one is in 5 seconds, sorry. So this one is in 5 seconds. The reading here is 1.2. Dalam masa 5 saat, dia bergerak sejauh 6 meter. Okay, tapi dia punya velocity dia constant 1.2 meter. Dia tidak memecut. So when we calculate the gradient of graph V against T graph, gradient ini tak ada. This is the horizontal straight line. So no gradient. So gradient M equal to 0. Therefore, acceleration is also equal to 0. That's why here, in 5 seconds, the acceleration is 0. Okay. Okay, next. Alright, look at this pattern of the graph. Okay, we have curve graph. Okay, so now look at this graph as against T graph. The object is still moving in positive direction. Okay, so from 0 meter to 6 meter. Okay, let's say this is in meter. Okay, and let's check about the velocity. Increasing, constant, or decreasing? Okay, let's check the velocity. Increasing, decreasing, or constant? So, from graph S against T, look at to the gradient of the graph. So, let's try to sketch. So, I want to draw a triangle. Let's say from here, at this point, sorry, macam tu. So, gradient. Kita lukis triangle kita kat sini. Kita tengok. Curam tak? Oh, tak terlalu curam. How about this point? Okay. So, the gradient becomes steeper. Kat sini pula. Oh, kita lukis dia semakin curam. What happened to the gradient? The gradient is increasing. Okay. The gradient is increasing means that for graph S against T, kita boleh tahu when the gradient is increasing, the velocity also increase. Okay. So now, here we can see from 0 to certain time. Okay, let's say we put as 5 seconds. We can see that the velocity, the reading of the velocity is increasing from 0, 1, 2, 3, 4, 5, 6, 7. Contohnya kan. Okay, sampai 7 meter per second. Contoh. Okay, ini awak kena kira lah. Okay, saya padam 7 awak kira. Okay, ini contoh. And from graph V against T, we try to sketch the gradient. So this is the straight line graph. So at any point of the graph, the gradient is constant. Let's say at 1 second, at 3 second, at 4 second, the gradient is constant. Okay, the gradient is constant means that the acceleration from 0 to 5 seconds also constant. Sorry, also constant. Okay, so 0. So constant tu berapa? Berapa yang constant tu? Berapa nilai dia? How to calculate? So we need to calculate the gradient. The gradient is constant, but what is the value? We need to calculate the gradient A. Okay, based on the graph, kira lah dia punya gradient. V2 minus V1 over T2 minus T1. Okay, so kita akan dapat satu ni nilai yang positif. Okay, so from C, acceleration is constant, which is at positive value here. Okay, and the object is accelerate in positive direction from 0 to 6 meter in positive direction. Okay, let's say gerak ke kanan positif ataupun ke hadapan. Okay, okay, dia bergerak, dia memecut. Okay, So, laju meningkat from 0, 0, 1, 2, 3 dan seterusnya meningkat sehingga ini. But how about the acceleration? The acceleration is constant. Okay, at one value of positive value. Okay? Alright, next. Okay, how about this one? Okay, look at the graph S against T. Okay, kita nak tahu. Let's say line kita letak lagi sekali 5 second. So, we want to know in 5 second, what happened to the velocity? Is it increasing, decreasing, or constant? Okay, so we try to sketch. Okay, let's try to sketch the triangle. Let's say at this point. Okay, oops, sorry. Okay, kita lukis. Okay, what about the gradient? I think that one is the steepest one compared to this one. Dekat point ini, oh, semakin mendata lah. How about this one? Semakin mendata. Okay, you can see here, the gradient of the graph S against T is decreasing. Means that, gradient tadi mewakili apa untuk graph S against T? Velocity. Means that the velocity is decreasing. Okay? And the graph from 0 to berapa ni ya? Kita letak lagi 6 meter. It's still moving in positive direction from 0 to 6 meter. But the velocity is decreasing. Okay, velocity decrease in positive direction. Okay, so we need to calculate what is the value of the velocity. Okay, boleh? Okay, so ini kita tak ada nilai, kita tak boleh kira lah. So sekejap lagi kita tengok example. Okay, so now this one is 0 to 5 second. Okay, you can see here the gradient is decreasing until 0. Okay, so this one, what is the value here? Okay, kita tak tahu. Tapi the pattern, okay, it's decreasing, decreasing, the velocity decrease until 0 reading. Okay, alright. So now this is meter per second. So now what is the gradient of the graph VT? So straight line graph, okay, straight line graph but in negative. Okay, negative value. Okay, kalau kita kira gradient ni, kita akan dapat gradient dia adalah negative value. Sebab apa dia negative value? Okay, kita kira dulu nanti. So, look at here, this is the straight line graph. At any point of the graph, let's say at 1 second, let's say 2 second, 3 second, 4 second, the gradient is constant. Okay, means that the acceleration is constant. Okay, acceleration is constant, positive or negative? Okay, we need to calculate the gradient. So, after the calculation, kalau kita tengok pattern of the graph pun, kita nampak the pattern is the negative gradient pattern. So, kita akan dapat nilai A dia adalah negative. Kita dapat negative. Okay, this one. A is negative. So, that's why here, the value here is negative value. Okay? A is constant, acceleration is constant. Maknanya dia constant saja sepanjang 5 second ini. In 5 second, the acceleration is constant, which is negative. Okay, negative value means that, in this case, negative acceleration. Means that the object is, okay, okay, the object is decelerate. Betul lah dia decelerate tadi kan? Kenapa? Because the velocity is decreasing. Okay, remember? Velocity tadi kita kira, velocity is decreasing. Okay? Okay, so next. How about this one? Okay. Object is moving in negative or opposite direction. Yes. Okay, the object is still moving. Okay, let's say it starts at point of 6 meter. Contohnya kan. At 6 meter. So, at 0 second, the position of the object is at 6 meter. Lepas tu, 1 second, 2 second, 3 second, 4 second, 5 second, 6 second. Until 6 second, dia sampai dekat 0 meter. Dia patah balik. Okay. Kalau kita ada lukisan. Okay, means that at this point, okay, 0 meter here, 6 meter here. Means that the object is moving in opposite direction, negative direction or to the left. Dia patah balik. Selama berapa saat? In 6 seconds. Okay, saya bagi contoh 6 seconds. So in 6 seconds, the object come back to its original point ataupun come back to its starting point. Okay, and how about the gradient? So remember, this is the straight line graph. So at any point of the gradient, dekat 1 second ke, 2 second, 3 second, 4 second, at any point, okay, kalau kita lukis triangle, at any point, the gradient is constant. The gradient is constant means that the velocity is also constant. So when the velocity is constant, boleh kira tak nilai dia? Boleh. Look at to the pattern of the graph as against T. The pattern of the graph is negative pattern. Okay, so maknanya V dia constant tapi in negative direction. So the value of V must be negative value. Okay. So that's why here the reading here is negative. Oh, sorry. Negative. Okay. And acceleration is 0 because the gradient here is equal to 0. So kita pun lukislah dekat sini. So in 6 seconds, it's moving in negative direction. But the velocity is constant at negative value because it's moving in negative direction. Okay, remember, velocity can be positive or negative based on its direction. Okay, based on its direction. So now the value of velocity is negative means that the direction of the motion is to the left or in opposite direction. So now acceleration is always equal to 0. Okay, so in 6 seconds tadi, okay, it's moving in, in 6 seconds tadi, the acceleration is equal to 0 meter per second square. Okay, next. Okay, this one. Okay, first, let's draw the triangle. Okay, let's start. Okay, let's say this point. Oh, you can see here the triangle. And how about this point? Okay, the gradient becomes steeper. Kat sini lagi lah kecerunan dia semakin bertambah. Okay, that's mean from here, let's say 6 meter to 0, the object is moving in opposite direction. Dia patah balik kepada 0 meter, from 6 meter to 0 meter in 6 seconds. Okay, but the velocity is increasing. Kenapa saya kata velocity is increasing? Look at to the gradient. Okay, semakin curam. Okay, so the gradient is increasing. Okay, means that the velocity is increasing. Okay, so from here, from 0 meter, okay, 6 meter. So the object back to its starting point. Patah balik ke sini, but dia memecut. The velocity is increasing. Okay, so what is the pattern of the graph? Alright, look at here. Look at here carefully. From 0 to 6 seconds. Okay, so 0, 1, 2, 3, 4, 5, 6. Okay, semakin meningkat. The value is negative because of the direction. Tapi the magnitude, nilai dia bertambah. 0, 1, 2, 3 dan bertambah. But the negative value based on the direction of the motion tadi, the direction of the motion is opposite direction. Okay, remember, velocity is increasing. Here, the velocity is increasing, but okay, bila kita lukis, increasing from 0 to certain value lah, bertambah. 0, 1, 2, 3, 4, 5, 6 for example. But the value is negative because of the negative direction. Okay, maknanya dia bergerak tadi, patah balik. Dia patah balik ke sini. Negative direction tapi dia punya velocity bertambah semakin laju sampai dekat starting point 0 meter. How about the acceleration? So when we try to draw the triangle, okay, kalau you confused, you lukis triangle. Oh, straight line graph, triangle dia sama, constant di mana-mana pun at any point here. 1 second ke, 2 second, okay, 3 second for example. So the gradient is constant. Gradient is constant. Okay, gradient is constant. So when we calculate the gradient, kita masukkan nilai. So the gradient is constant but negative value. Okay, so means that the acceleration is equal to negative value. Constant tetapi pada negative value. Nampak sini? Negative value. Constant. From 0 to 6 second, it's constant. Okay. Alright, good. Next. Okay, same goes to this one. Alright, let's draw. So look at here, the triangle. Okay, the gradient becomes steeper or decreasing. Okay, look. Okay, look at here, the gradient become. Okay. The gradient is decreasing, right? Okay, kecerunan dia semakin berkurang. So, bila kecerunan dia berkurang, maknanya apa? Velocity is decreasing. Gradient is decreasing. Velocity is decreasing. Okay, objek tu bergerak ke mana? Kita kena tahu dia bergerak ke mana. You start from here at 0 second. Let's say this here is 6 meter. Asalnya sama tadi, 6 meter. Dia patah balik kepada kosong. 0 meter. So, the position of the object here, 6 meter. The object is moving in opposite direction. Come back to its original ataupun at starting point lah. Original position tadi. Asalnya. Okay, dia patah balik. But, the velocity is decreasing. Okay, velocity decreasing. Semakin perlahan. Semakin dah nak sampai dekat 0 meter tu, semakin dia slowing down. Okay. So, kita baca, object is moving in negative direction, opposite direction, velocity is decreased. Okay. So, velocity decrease in negative direction. Okay. So, kita lukis kita punya graf dekat bahagian negatif. Kenapa? Sebab in negative direction. Alright. So, now, so let's write here. Contoh 0 meter per second. Okay. So, let's say in 6 second tadi, so dia berkurang. Contoh 5, saya tak number so awak nampak, negative 5, 4. Kenapa value dia negatif? Because it's moving in negative direction. Dan tengok sini, value dia semakin menghampiri kosong. 5, 4, 3, 2, 1 and then 0. At 6 second, here, the velocity is 0. Semakin berkurang. Okay, velocity decrease in negative direction. So, nilai dia mesti negatif dan semakin berkurang. Okay. Velocity is decreasing in negative direction. Dia patah balik dan semakin perlahan. Okay, so kita kena tahu. And how about the value? Okay. Okay, kita kira dia punya gradient here. So, when we calculate the gradient, kita akan dapat nilai M, the value is positive. So, the value of the acceleration is positive. Kenapa value dia positif pula? Sebab dia bergerak in negative direction and it's slowing down. Okay? Decelerate. Okay, object is decelerate. Okay, constantly. Okay? Object decelerate in negative direction. So, after the calculation, kita akan dapat A kita positif. Okay? So, kita akan dapat nilai dia positif dekat sini. Tapi dia mendata lah. Okay, selama 6 second tadi, in 6 second, static saja dia punya acceleration. Okay, acceleration dia maintain dekat satu bacaan sahaja. Okay, good. Okay. So now, oops, sorry. Okay, now, so look at here. Okay, the summary. If we have graph S against T graph, gradient dia akan bagi you velocity. Okay, if you have graph V against time graph, the gradient will give you acceleration. And how about the area? If you have the graph of AT graph, the area of the graph will give you velocity. And for the graph of V against T graph, this will give you the value of displacement. Okay, area under the graph. So, this is very important. Okay.
Okay, so now look at to this question. Question number 1. Look at here. At 0 second, the position of the object is at 0 meter. Okay, and then the object will move to 40 meter in 2 second. Dalam masa 2 saat, dia dah sampai 40 meter. Okay, so it's moving. Alright, so when at 40 meter, okay, what happened to the object? They stay at 40 meter in another 4 second. Okay, from 2 second to 6 second, dalam masa 4 saat, objek itu tidak bergerak. So, it stay at 40 meter. And from 40 meter, okay, so it's moving in opposite direction, okay, which is 20 to 20 meter in opposite direction. 20 meter, okay, so dia patah balik 20 meter dalam masa 2 seconds. Okay, so come back to 20 meter. Alright, and here, from 8 to maybe 11.6 second, what happened to the object? From 20 meter, it's moving, okay, to the right. Okay, it's moving to the right in positive direction. So this is in positive direction until 60 meter. Alright, so the star is moving to 60 meter. Okay, so that's the motion of the object. So now, let's try to answer the question. Okay, so this is the concept and test your understanding. Okay, question number 9. Okay, at point A, the object is, the object is moving to the right or moving to the left, opposite direction, or stop or accelerating. Okay, so now look at here, from 0 to 2 second, okay, this is graph S against T, displacement against T graph. Look at the gradient is constant, means that velocity is constant. When velocity is constant, means that acceleration here is equal to 0. Okay, please write here, acceleration here is equal to 0. So, it's not accelerate. Okay, it's not accelerate. Okay, so D salah lah. Okay, the object is moving to the right. Betul tak it's moving to the right tadi? Yes, the start is from here, from 0 meter to 20 meter to the right. Betul. Moving to the left, salah. Stop pun salah. Kenapa tak stop from 0 to 4 second? It's moving. So, the answer is A. Okay, and B. Okay, so B, at point B, the object is stopped. Alright, so tadi kita dah kata, so the object is stopped at 40 meter. So, selama berapa second? From 2 to 6 seconds. Okay, so it stopped selama 4 second. Okay. Okay, now so look at point C. Okay, at point C, the object is, okay, look at point C. The motion of the object tadi, from 40 meter, it's moving in negative direction or opposite direction. Okay, from 40 meter, here, it's come back to 20 meter. Alright, it's come back to 20 meter. Alright, and so this is a straight line graph. So we know that the gradient is constant. The velocity is constant. Okay, and at point C, the object is moving to the right. Salah. Moving to the left. Betul. Stop. Dia tak berhenti. Okay, accelerating. Dia memecut ke? Okay, tidak. Because the velocity is constant. Okay, so the answer is B. Okay, so now look at point D. Okay, I'm going to find what is the gradient of this line. Okay, I think I want to take this one as 12. Okay, ada ralat dekat sini. Line ni awak tarik sampai 12 Okay, sebab nanti tak ada jawapan dekat point D. So, we want to find the velocity at point D. So, the velocity at point D, we write as VD. So, the gradient along the line y2 minus y1 over x2 minus x1. Okay, so now, so this is y2, 60, paksi y at this point, 60, and this is 20. So, 60 minus 20 over, and x2 is 12, 10, 11, 12. So, 12 minus 8. Okay, so 12 minus 8. Alright, so the answer is 10 meter per second. So, the velocity at point D, or the velocity at any point on this line, tak kisahlah D, E, F, G, ataupun dia tanya, what is the velocity at 8.9 second? Macam mana nak cari 8.9 second, cikgu? Tak boleh nak baca. Okay, kononnya kan? 8.9 second. Okay, so kalau sebut 8.9 second, 10.2 second, 11 second, or 9.3 second, so the velocity from 8 to 12 second must be constant. Okay, sama, tetap, mala. Okay, this one. Alright? Okay, good. Okay, so now let's continue. Okay, with question number 2. Okay, so we have VT graph. Okay, you can see we have 4 questions here, and the highlighted answer is the actual answer lah. Okay, so using the velocity graph, answer the following questions. So remember, for graph VT graph, okay, so the gradient, oh sorry, okay, we reduce. So the gradient, this one, okay, so the gradient of the graph must be its acceleration of the motion. Okay, please remember that. Okay, so we have 4 points here. So we have 4 points here. Okay, we have A, B, and C. Alright, so now I want to highlight. Okay, I want to highlight A. No, I don't want that one. Okay, so I want to highlight A. Oh, sorry. Now I want to use the highlighter. Okay, I want to highlight A, and then we have B, and then we have C. What color? C here, and then the last one is D. I think I want to use pink. No, maybe green. Okay, done. Okay, D. Okay, here. Okay, so we have A, B, C, D. Alright, so at point D, the object is, okay, look at point A first. Okay, so now let's discuss point A first. Okay, I want to write point A. Okay, okay, let's look at point A. So at point A, the object is moving, okay, from 0 to 4 seconds. Okay, from 0 to 4 seconds. Okay, from 0 to 4 seconds, the object is moving. Okay, and it's increasing its speed. Okay, ataupun kita kata the velocity is increasing, okay, in positive direction. Okay, means that the object is moving to the right and the velocity is increased from 0 here to 20 meter per second. Okay, selama 4 saat tadi. And what happened from 4 to 8 seconds? No, from 4 to 7 seconds. 4 to 7 seconds, you can see here the object is still moving. Okay, saya tulis object still moving, but okay, ataupun kita kata object is still moving with constant velocity. Velocity dia tetap. From 4 to 7 seconds, selama 3 saat tu, velocity dia tetap. Constant at 20 meter per second. Okay? And how about from 7 to 9 seconds? Okay? From 7 to 9 seconds, the object is still moving, but the velocity is decreasing. Okay? From 20 meter per second, okay? And then from 20 meter per second, and then decrease until 0. At point C, the velocity is 0. Okay, and it's still moving in opposite direction, okay, with 20 meter per second. Okay, negative 20 meter per second. Okay, so when we calculate here from 7 to 9, okay, the velocity is decreasing until 0 lah, until 0 meter per second. Okay, and from 9 to 11, from 9 to 11 seconds, okay, so from 9 to 11 seconds, the object is moving in opposite direction. Okay, dia patah balik, opposite direction. Okay, and the velocity is increasing. Okay, look at here, from 9 to 11, here is 0 meter per second, and then they decrease. 1, 2, 3, 20, 40. Okay, this one should be not 40, 30. Okay, 20. Okay, from 9 to 11 seconds, the velocity is increasing. Alright, it's moving in opposite direction, that's why the velocity is negative. Okay, moving in opposite direction, but velocity is increasing from 0 to 20 meter per second. Okay, okay, good. Okay, and from 12 second, okay, from 11 to here, 12, 13, 14, okay, let's say here is 14, okay, from 11 to 14 second, what happened? Okay, it's still moving in opposite direction. Okay, saya sambung ke atas ni ya. From 11 to 14 second, the object still moving in opposite direction. Okay, but this time with constant velocity of 20. Okay, so with constant velocity, okay, iaitu 20 meter per second. So we have negative value because it's moving in opposite direction. Okay, okay, good. Okay, let's move to the next question. Okay, so now we get question number 1. At point D, the object is moving to the left. Okay, nampak tak tadi? Opposite direction. Okay, good. Okay, moving to the right, no. Decreasing its speed, no. The speed is constant. Okay, below the ground, no, it's not applicable. Okay, so now at point C, the object is at point C. Look at here at point C. Okay, the velocity is 0. Dia stop sekejap, lepas tu baru dia sambung. 0 meter per second, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. Okay, stop. Because C, velocity is 0, so it stop. Here, the velocity is 20, constant velocity, and then the object start decreasing its velocity until 0. Stop sekejap, and then dia teruskan ke direction yang bertentangan. At point B, the object is moving to the right. Yes, it's true. Okay, from here, from 0 to 4 seconds, it's moving to the right. And from 4 to 7 seconds, it's continue to moving to the right with constant velocity of 20 meter per second. It stopped? No, it's not stop. It's not static. Because this is not graph S against T. This is graph V against T. So it's still moving with 20 meter per second speed. Okay, moving to the left? No, it's moving to the right. Okay, look at to the area of the graph. The area of the graph is positive right. Okay, ke atas. Kalau kat bawah ni baru opposite direction. Okay, accelerating? No, it's not accelerating. Okay, so it's moving with constant velocity 20 meter per second. Okay, the displacement of the object at point C is 120 meter. So we want to calculate the displacement at point C. Dia dah bergerak sejauh mana? Okay, so we need to calculate the area under the graph. From here, from 0 to 9 seconds. Okay, so let's continue to calculate the area under the graph. Okay, so now we want to calculate the area under the graph for question number 2. Okay, we want to calculate the displacement. Okay, the displacement at point P. At point C. Okay, so now I want to calculate first the area under the graph from 0 to 4 seconds. Okay, it's a triangle. So half times 4 times 20. So it's equal to 40 meter. Okay, and then from 4 to 9 seconds. So it's a trapezium. Okay, so half. I slightly calculate the trapezium shape. That one, So half. That one 4 minus 7, 3 plus 4. 7 minus 4 is 3. 9 minus 4 is 5. Okay, and then times the height is 20. So this should be, so 80 here. Therefore, the displacement, okay, we need to total because it's moving to the right. Okay, this one I want to write moving to the right. Okay, and this one also moving to the right. Dia teruskan perjalanan. Okay, so therefore the displacement, okay, is equal to 40 plus 80. So the answer is 120 meter. Okay. Okay, good. Okay, let's proceed to question number 3. Okay, so now let's continue question number 3. Okay, so this is a graph of V against T graph. Alright, velocity in meter per second and time in second. The graph below shows velocity as a function of time for some unknown object. What can we say about the motion of this object? So kita akan tengok motion dia nanti. Plot the corresponding graph of acceleration as a function of time. So before we answer these two questions, question A and B, I want to calculate first what is the area under the graph. Okay, so now let's look at to the question. Okay, so look at here from 0, okay, now look at here from 0 to 4 seconds. Okay, we want to calculate area under the graph. Okay, let's say the area under the graph is this one. Okay, we want to calculate what is the area under the graph for the yellow color here. Okay, so it's half. So I want to name it as area A. So A, it's half times 4 the base and times 0. So this is 4, positive 4. Okay, so it's equal to 8 meter. Okay, and how about point B? So this is point B. Okay, so area B, okay, it's a trapezium. Okay, so I want to color. Okay, we want to find this one. Okay, so this is a trapezium shape, but remember it's a negative, right? Okay, so point B. So area B, we want to calculate half times, so it goes from 4 to 16. Okay, so 16 minus 4 is 12. So 12 plus, so this one 5, 6, 7, 8, 9, 11, 12. So 12 minus 8, 4. So this is 12 minus 8, so this is 4. Times the height is negative 4. Okay, here, so we have a negative, right? So this is negative 4. Okay, okay, so it's equal to negative. Okay, this one 12 plus 4, 16 minus 2. Okay, negative, okay, 32. Okay, how about C? Okay, so this is 30. Okay, let's say C. This one is C. Okay, so for C, we want to calculate C. It's also a trapezium shape. So C half times, so this one should be 24. Alright, so 20 to 30 is 10. 10 plus 24 to 30 is 6. Okay, times the height. Okay, so look at here, the height is, okay, the height is 3, right? So the height is 4. Is it? The height is 4. Okay, so it's equal to, so 16. So 16 minus 2. So we still have 32. Okay, so this one is 32, negative 32. Okay, so alright. So now if we want to find what is the displacement or distance. Okay, if the question asks you calculate the distance traveled by the object. So distance traveled by the object, we need to calculate the whole. Okay, the whole value of the area under the graph. By ignoring the negative sign. Okay, because distance is a scalar quantity. Okay, so distance we need to calculate. Okay, the whole distance of the object. So it should be 8 plus 32 plus 32. So now it's equal to, okay, so the answer should be, okay, 72. Okay, but for the displacement, okay, because for distance it's a scalar quantity, so no direction, so we ignore the negative sign. But for displacement, in your calculation, we need to take negative sign in the calculation. Sorry, this one. Okay. Alright. So it should be 8 plus negative 32 plus 32. Okay. Answer. So it's sorry. This one should be 32. It's equal to 8 meter. Okay. So the distance traveled by the object is 72 meter, but the displacement is 8 meter. Okay. So I want to highlight here from 16 to 20 seconds, okay, the object is not moving. Why? Here V is equal to 0 meter per second. The object is at rest. Dia berehat selama 4 second. From 16 to 20. Okay. So tak ada distance lah dekat situ. Okay. Alright. Good. So now let's try to describe the motion of this object.
Okay, now look at question A. What can we say about the motion of this object? Alright, so at 0 second here, you can see at 0 second, the velocity is here, 4 meter per second. Whatever this thing is, it's already moving forward. So that's mean, masa kita mulakan waktu 0 second tu, kita start je timer. So the object is moving here. Okay, kita mula dengan objek itu bergerak, already moving forward. Okay, so it's 0 meter here. Okay, kita calculate 0 second here. Alright, so from 0 to 4 second, okay, kita dah kira tadi, the area under the graph is equal to 8 meter. So from 0 to 4 second, the object is moving, okay, sejauh 8 meter. Okay, so it's moving. Alright, so from 4, okay, look at here. From 4 to 5, 6, 7, 8, from 4 to 8 second, okay, what happened to the object? The object is reverse direction and it's going faster. Why? Because the velocity is increasing. 0, 1, 2, 3, 4, and then until 5. Okay, from 4 second to 8 second. Okay, the object is moving in opposite direction, the reverse direction. Okay, and it still keep moving. Okay, still keep moving, still moving backward. Okay, but now is constant speed, -5. Okay, and then it's still moving backward. Okay, until it stops, slowing down and then stop at 0 meter per second. So the area under the graph here, okay, is the distance traveled by the object. It's moving in direction, opposite direction. Okay, so dia akan bergerak From 4 to 15 second, kita dah kira tadi, -32 meter means that it's going in opposite direction sejauh 32 meter. Okay, so it's going in opposite direction. So this is -32 meter. So 8 plus 24 meter here. Okay, so another 4 meter, 0 plus 0 to 24 plus 8, 32. Okay, so -32 meter. Okay, so what happened to the object here? The object is not moving. Okay, this time for a few seconds, from 16 second to 20 second, the object is not moving. Okay, berhenti sekejap dekat Y. And then what happened? From 20 second to 30 second,
it's still moving in positive direction to the right. Okay, so here we see it moving forward and accelerating forward uniformly. Okay, and then this one, the object is still going forward, but the speed is no longer increasing, means that constant speed. Okay, tapi tengok area under the graph tadi, kita dah kira positive 32 meter. So, Y, the star will move to the X again. Okay. Okay, so you can see, here is the starting point, 0 meter, and the displacement, kita kira tadi 8 meter. Starting to ending point is 8 meter. But the distance travel, keseluruhannya, the distance travel by the object is 8 plus 32 plus 32. And the answer tadi kita kira, berapa? Berapa tadi kita kira? Is 72 meter. Okay, 8 plus 32 plus 32, total 72 meter. Okay, so now look at to this graph. Look at to the velocity of the graph, okay? Kita tengok lagi sekali. Okay, from 0 to 4 second, okay, the object is moving forward until 8 meter. But you can see here, the speed is decreasing. 4, 3, 2, 1, 0. Whatever, okay, so this one. The speed of the object is decreasing uniformly, but it's still moving forward. Dia bergerak ke depan tapi semakin slow sampailah 8 meter. Okay, the star is moving forward until 8 meter. Okay, and the object stops here. V is equal to 0, but only for an instant. Sekejap saja. Okay, and that's moving forward. So 0 tadi, dah 0, lepas tu dia tambah lagi. Okay, the speed is increasing. 1, 2, 3, 4, 5. 4 here. Okay, it's going faster because the speed is increasing, but in negative direction. That's why we have -4, -3. Okay, because the direction is opposite direction, reverse direction. But for the -4 here, you can see the speed is constant. Tapi jangan lupa, here the speed is constant, but the object still moving backward. Dia masih bergerak tadi from 8, bergerak, laju sikit, laju, and then constant speed here. Constant speed, and then until point Y, the speed is decreasing, the slowing down sampai Y. Tengok here, we have 4, -4, -3, -2, okay, -1, and then 0. Still moving in negative direction, moving backward, but slowing down. Okay, lepas tu dia rehat sekejap. 16 to 20, stop, at rest, stationary, it's not moving. And then from 20 second to 24 second, what happened to the object? Here, we see it moving forward. Okay, from Y, dia bergerak ke kanan. Tapi kali ni dia laju. From 0 meter per second, increasing to 1, 2, mana tadi arrow saya? From 0 second, 1, 2, 3, 4, 5, dan seterusnya. Okay, sampai sini. 4 meter per second here. Okay, you can see 4 meter per second. Okay, and then it keep moving forward, but now, dia tidak lagi speed up. Okay, because the speed is constant here at 4 meter per second. Tapi dia masih bergerak sampai sini. Okay, so keseluruhan perjalanan dia adalah 30 second. From 0 to X to Y and come back to X. Okay, the whole journey is 30 second. Okay, so let's proceed to question B. Okay, now question B, the question asks you to plot the corresponding graph of acceleration as a function of time. Okay, so you want to sketch graph of A against T. Okay, so before we start, look at to the graph V against T. Okay, we need to calculate the gradient of the graph first. Alright, so let's start. So I want to start with from 0 to 5, 6, 7. So 7 here. Okay, from 0 to 7 second. So the gradient of the graph represents the acceleration of the motion, where A is equal to, okay, so this is initial point and this is the final point. So the final point is -4. Okay, -4. Divide. So we have 5, 6, 7, 8, 8 second. Final point 8 second minus T final minus T initial is 0. So the answer is -8 divide 8. So it's -1 meter per second. Oops, sorry. Meter per second squared. Okay. This one. Mana-mana? Okay, this one. Okay. -1 meter per second. So let's use another color. Okay. This one. Okay. So now the object is moving with constant velocity here. So here velocity is equal to -4 meter per second. So it's constant. Okay, therefore acceleration is 0. Okay. How about this one? From 12, okay, from 12 second to 16 here. Okay, let's calculate the acceleration. Let's calculate the gradient. So let's use the red color now. Okay, so A is equal to, so we are calculating this one, right? Okay, from here, initial, this is final. Okay, this is very important. Awak mesti pastikan initial dengan final jangan salah poinnya. Nanti positif negatif awak jadi salah. Okay, so negative is equal, negative pula. Okay, so A is equal to, okay, Y is negative 4. Final dia berapa tadi? Sorry. A is equal to, final is 0 minus initial is negative 4. Divide. Okay, so we have X is 16 minus 12. 16 minus 12. So it's 4 divide 4. So acceleration is positive 1 meter per second squared. Okay, so inilah. Okay, kita dah kira. Okay, so you tengok masanya 0 to 5. No. 0 to 7. 7 to 12. 12 to 16. This is very important in order to plot a T-graph. Okay, later. Alright, so from 16 to 20, it's not moving. It stopped. Okay, so A is equal to 0. And from 20 to 20, 21, 22, 23, 24. Okay, so 24 here. So 24. So calculate the gradient. Same goes to this one. Okay, we have final. This is final. This is initial. Okay, this is final. This is initial. Okay. So now calculate. Final is 4. 4 minus 0. Divide 24 minus 20. Okay, so 4 divide 4 is positive 1. Okay, so yes, kita dapat positive 1. Okay, and then this one is not moving, so it's equal to 0. Here is not moving. It's not moving. Sorry. Salah. Okay, so now A is equal to 0 because V is constant. V equal to positive 4 meter per second. It's constant. Okay, so acceleration is equal to 0. Okay, so now let's try to plot the graph. Okay, so when you look at to all the values, you can see here. Okay, so let's say I want to use what color now? Let's say I want to use green color. Done. Okay, so this one should be 1, graph 1, graph 2, 3, 4, 5, 6. Okay, so now let's start from 0 to 7 second. Okay, from 0 to 7 second here. Okay, you can see here it's negative 1, so kita gariskan negative 1. Okay, it's constant acceleration. Okay, constant acceleration equal to negative 1. From 7 to 12 second, acceleration is equal to 0. Okay, and then we continue from 12 to 15. 12 to 15 is positive 1, so you garis kat sini lah, positive 1. And then from 16 to 20, okay, so 16 to 20, A is equal to 0, so now A is equal to 0. From 20 to 24, 20 to 24, we have calculated the acceleration. A is equal to positive 1. Okay, so 24 to 30 second, come back to A equal to 0. So kita dapat buat dengan baik. So this is graph 1. Okay, graph 2, graph 3, graph 4, graph 5, and graph 6. Complete. Okay, right? So make sure when you plot a graph A against T from graph V against T, make sure the timeline is a correct timeline. Okay, maksud saya, tengok masa ni lah, 5 second, 7 second, baca betul-betul. So letak, tak boleh lah, you buat from 0, let's say you buat from 0 to 6 second. Okay, lepas tu you garis. Padahal dia sampai 7 second. Okay, so tengok betul-betul. From 0 to 6 seconds, salah. From 0 to 7 seconds, betul. Okay, A is negative 1 meter per second squared. It's constant from 0 to 7 seconds. Okay, alright, good. let's proceed to question number 4. Okay? Kalau you rasa penat, you boleh bangun, ambil air, minum sekejap, exercise sikit, nanti kita sambung kejap lagi. Okay, good.
Okay, so now let's continue with chapter number 4. The graph shows the position of an object that is moving along a straight line that runs north-south, with north being the positive direction. Okay, north and north to south. Okay, how far does the object move during the first 3 seconds?
So, question number 1, how far does the object move during the first 3 seconds? Okay, so during the first 3 seconds, sejauh mana dia dah bergerak daripada its original position. Okay, so from the graph you can see here, from negative 4, so back to 0 and move to 8. Okay, so means that from here, negative 4 meter, move to 0 meter, and here move to 8 meter. Okay, so how far? So this is the starting point. Okay, so question number 1. So starting point, this is the ending point. So sejauh mana dia dah bergerak? So here is 4 meter and this is 8 meter. Alright, so how far? So the answer is the distance. Alright, so the distance traveled by the object should be equal to 4 plus 8. 12 meter. Okay. Alright, so that's the answer, 12 meter. How fast? How fast is the object moving at 1 second? Okay. How fast? Okay, how fast? So means that in 1 second, so we want to calculate what is the speed, the velocity at 1 second here. Okay, so we need to calculate the gradient, this gradient. Okay, so let's calculate the gradient. So the gradient is equal to, okay, y, this is initial and this is initial and this is final. Okay, so final minus initial. So 8 minus negative 4 and x is 3 minus 0. Okay, so 12 over 3. So the answer is 4 meter per second. Okay, this one should be V lah. Okay, so 4 meter per second. So from 0 to 1 second, 2 second, 3 second, at any point here, okay, here the velocity is 4 meter per second. Here is also 4 meter per second. Here, here, here. Okay, all the way, okay, from 0 to 3 seconds, the velocity is 4 meter per second. Okay, you must know, okay, velocity is constant. The gradient is constant, right? So the velocity is constant from 0 to 3 seconds. Okay? Alright. Let's continue. 3. What is the velocity at 1, 4, and 7 seconds? So at 1 seconds, kita dah kira tadi. Okay? So at 1 seconds, the velocity is 4 meter per second. And how about the velocity at 4 and 7? Okay, you can see here at 4 seconds, let's use another color. 4 seconds here, the velocity is 0. Okay, why? Because it's not moving. Here, the gradient is 0, so the object is at rest. So 0 meter per second. So I can answer here. Okay, where at 4 seconds, the velocity is 0 meter per second. And the last one, we want to answer at 7 seconds. What is the velocity at 7 seconds? Okay, at 7 seconds, okay, we need to calculate this gradient, the purple color. Okay, so you need to calculate the purple color. So the gradient is equal to, V is equal to, okay, so this one should be, okay, this is initial and this is final. Jangan salah tau. Okay. So, 2 minus 8. Final minus initial. 8 minus 5. Okay. So, it's equal to, berapa tu? Okay, negative 6 divide 3, negative 2. Okay, so the answer is 4. Dia tak keluar pula. Okay, the answer is 4, 0 and negative 2. Okay, next. What is the acceleration at t equal to 7 seconds? Okay, the acceleration. Alright, so as we know, okay, from 5 to 8 seconds, okay, the velocity is constant. Okay, therefore, when the velocity is constant, the acceleration is equal to 0. Okay, so we know that from 5 to 8 seconds, the velocity is constant. Okay, which is negative 2 meter per second. Tadi kita dah kira kan? Okay, where v is equal to negative 2 meter per second. Okay, so A is equal to 0. Okay, so next. Kalau dia tanya 6 second pun jawapan dia sama lah. What is the acceleration at t is equal to 6 seconds? So the answer is still the same, 0. Okay, alright, next. What is the total displacement? Alright. Okay, so we want to calculate the total displacement. Okay. Okay, so how to calculate the total displacement? So in order to calculate the total displacement, make sure you consider the negative sign of the value lah. So this is graph S against T. So kita boleh baca terus daripada graph. Alright, so now let's start. Okay, the total displacement. Okay, so now from negative 4 to 0. Okay, so kita lukis. Let's try to draw the timeline. So start from here. So negative 4. Okay, and then move here. Okay, which is, this is 0 meter. And then, okay, negative 4 to 0, 0 to 8 meter. Okay, so we have negative 4 and 0 to 8 meter. Okay, 0 to 8 meter. So here is 8 meter. Okay, so 0 to 8 meter, and then it stay at 8 meter for 2 seconds. From 3 to 5 seconds, the object stay at 8 meter. So dia tidak bergerak sini kan? So V is equal to 0 meter per second. So now, after reach 8 meter, what happened? The object is moving in opposite direction until 2 meter. Okay, dia bergerak dari 8 sampai 2 meter. So let's say the 2 meter is here. I want to use another color. Okay, so now let's draw. So from here to here, okay, negative 4 to 0. And then move to 8 meter, and then stay at rest, and then come back. So we have 1, 2, and 3. So what is the total displacement? So starting to the ending point. So here is the ending point. Okay, so now let's calculate the displacement. Okay, negative 4 to 0, so it's equal to 4 meter. Plus 8 meter, and plus its opposite direction. Okay, this is opposite direction, so it should be negative. Okay, should be negative, this one. Okay, so negative 8 minus 2 is 6 meter. So 12 minus negative 6, so the answer is 6 meter. Okay, so the answer is 6 meter. What is the average velocity? Okay, next, what is the average velocity? Okay, we want to calculate the average velocity. Okay, so average velocity, So the average velocity is equal to, okay, S final minus S initial divide T final minus T initial. Okay, so you can straightly read from the graph where S final is here, 2 meter. 2 minus initial is negative 4. Okay, and then T final, we know that the duration is 8 seconds. So 8 minus 0. Okay, so the answer is 6 divided by 8 is 0.75. Okay, so the last question is sketch a velocity time graph that shows the same motion. Okay, let's try. Label the y and x axis. So we have t. Okay, so from 0 to 8 seconds. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. Alright. And then we need to calculate first. Okay, the velocity from 0 to 3 seconds. Tadi kita dah kira. From 0 to 3 seconds. Okay, it's 4 meter per second. Is it? Yes, 4 meter per second. So let's say it's 4. So 1, 2, 3, 4, 5, 6, 7. Okay, so we know that from 0 to 3 seconds, the velocity is equal to 4 meter per second and it's constant. Okay, it's constant for 3 seconds. Okay, so let's draw the graph. Okay, so here again. Okay, nice. Okay, so now from 3 to 5 seconds, okay, let's write from 3 to 5 seconds, the velocity is equal to 0, not moving, at rest, stationary. Okay, okay, so it's from 3 to 5 seconds here. Okay, and then from 5 to 8 seconds is negative 2. Tadi kita dah kira kan? Okay, so it's negative 2. Okay, so from 5 to 8 seconds, so I have just calculated. So from 5 to 8 seconds, kita dah kira tadi where V is equal to negative 2 meter per second. Okay, it's constant. Okay, why it's negative value here? Why? Okay, because the object is moving in opposite direction. Ingat tak tadi? Okay, cuba kita tengok yang atas tadi. Okay, here from 0 to 8 and then the object is moving in opposite direction from 8 to 2 meter. Alright, that's why the direction of velocity is negative 2 and it's constant. Okay, so here, let's say I put negative 2 here. Okay, so how about the line? So it's constant from 5 to 8 seconds. So we put here. Okay, something like that. Okay, good. Okay, so this is the pattern of the graph V against T. Okay, alright, so we have finished question number 4. Okay, so now let's continue with question number 5. Okay, which about VT graph. Okay, the graph shows the velocity of an object that is moving along a straight line that runs east-west with east being the positive direction. Okay, how far does the object move during the first 2 seconds? Alright, how far, okay, does the object move? Okay, so we want to calculate the distance traveled. Okay, so how far? So question number 1. So how far, okay, does the object move? Okay, so we want to calculate area under the graph. Okay, since area under the graph will give the displacement of the object. So in 2 seconds, in the first 2 seconds, so this is 2 seconds, so we want to calculate what is the area under the graph. Okay, so area under the graph, okay, so is equal to, okay, 12 times 2. So the answer is 24 meter. Alright, so 24 meter. Okay, correct. How fast is the object moving at t is equal to 4 seconds? How fast? So we want to calculate what is the velocity. So actually, no need to calculate velocity. Velocity boleh dapat daripada graph. Okay, tak perlu kira. Okay, so okay, at 4 seconds, okay, you can see here. So at 4 seconds, okay, the speed is 8. Okay, something like that lah. Ni saya lukis sendiri. Okay, so at 4 seconds, so V is equal to 8 meter per second. Kita baca je terus. Okay, so number 3. Alright, number 3. What is the acceleration at t is equal to 1, 4 and 9 second? Acceleration at t is equal to 1 second, t is equal to 4 seconds, and t is equal to 9 seconds. Alright, so for the graph V against t, we need to calculate the gradient of the graph. Okay, so let's try to calculate the gradient of the graph, where at 1 second, so here, okay, I want to use, let's say I want to use the blue color. Okay, at 1 second, okay, read from the graph. So here, so the gradient at 1 second is equal to 0. So means that the acceleration from 0 to 2 seconds is 0 meter per second. Therefore, at 1 second, acceleration is equal to 0 meter per second. Okay, so next, at 4 seconds, okay, so we can calculate the gradient. So the gradient is the straight line. So from here to here, so we want to calculate what is the gradient at 4 seconds. Okay, so at any point, okay, along the line, so the acceleration at 4 seconds or the acceleration at 3 seconds, 5 seconds is constant, sama. Okay, so dia nak 4 seconds. So let's calculate the gradient. So at 4 seconds, the acceleration is V final minus V initial over T final minus T initial. So the gradient. So from at 4 seconds, so the gradient from here to here. Okay, so I want to calculate the gradient. Means that V final is 4. V initial is 12. T is 6 minus 2. So the answer is, so negative 8 divided 4, it's negative 2 meter per second squared. Okay, dia decelerate. Kenapa decelerate? So look at here. Okay, from here you can see, okay, the velocities here is 12 meter per second and then decreasing. Okay, uniformly. You can see here 12 meter per second, 10, 8, 6, 4 dan seterusnya sampai sini. Means that velocity is decreasing. Okay, means that the object is decelerate. Okay, so the answer is negative 2 meter per second. And the last one is 4 meter per second. So the answer is 4. Acceleration is equal to, okay, same goes to the previous part. We want to calculate what is the gradient from here 8 to 10. Okay, because we want to know what is the acceleration at 9. Okay, so here. Alright, so the gradient at 8, 9, 10, okay, is the same gradient. It's the same gradient, so same acceleration. Okay, so acceleration at 9 seconds, A is equal to, okay, so final, V final is 14. V final minus V initial, T final minus T initial. So V final is 14 minus, here is initial is 4. Okay, okay, look at here. Okay, from the equation. So this one is, oh sorry, this one is 16. Okay, sorry, this is 16. Here is 16. 16 minus 4. Okay, and the time here, you can see the time here 16 minus 4, and this is 10 minus 8. Okay, so the answer is 16 minus, so 12 divided by 2 is 6 lah. Okay, 12 divided 2 is 6. So the answer should be 6. Bukan 4 Ini soalan tu salah kat situ. 6 meter per second. Okay, so 6 meter per second. We want at 9 seconds. Okay, next, which direction is the object moving from 2 to 4 seconds? So look at here, from 2 to 4 seconds. Okay, so it's moving to the east to west, with east being the positive direction. Okay, so now start from here. So the object is moving, this one 12 meter per second, moving with constant. So tadi kita dah kira from 0 to 2 second. So from 0 to 2 second, from 0 to 2 second, okay, it's moving 24 meter. Okay, and then from 2 to 4 second, dia continue bergerak. Okay, tapi tadi objek tu bergerak 12 meter per second constant. Lepas tu dia berkurang dia punya velocity, tapi dia still bergerak ke arah positive direction, which is to the east direction. So dia tanya which direction is the object moving from 2 to 4 seconds. So the answer is east lah. Okay, ke kanan. So dia bergerak ke kanan, dia masih bergerak, and then here it still keep moving to the right. Okay, sekarang ni semua velocity kita semua positif, maknanya dia masih bergerak ke kanan. Okay, what is the total displacement of the object during the entire 10 seconds? Okay, so soalan yang terakhir. Okay, what is the total displacement? So let's calculate the area under the graph. Total displacement. Okay, calculate the area under the graph. If we look at to the graph, no negative area. Okay, semua positif. So we can calculate first from 0 to this one. Okay, this is the trapezium. Okay, from 0 to, tadi kita dah kira from 0 to 2 seconds. Okay, so from 0 to 2 seconds, okay, kita dah kira tadi 24 meter. And then from 2 seconds to 6 seconds, it's a trapezium. So half, okay, half times this one, 12 plus 4. Okay, this one 12 plus 4, ini dia punya tinggi dia lah. 6 minus 2, tinggi dia adalah 4 times 4. Okay, this one. So the answer is 32. Okay, so from 6 second to 8 second. Okay, so here we have a square shape here. So 4 times 2. Okay, so 8 meter. And the last one is 8 second to 10 seconds. So it's a triangle. It's a trapezium. Okay, still trapezium area under the graph. So the height is 10 minus 8, and this one is 4 plus 16. Half times 4 plus 16 times 2. Okay. So it's equal to 20 meter. Therefore, the total displacement should be 24 plus 32 plus 8 plus 20. Okay, so what is the answer? 24 plus 32, 24 plus 32 plus 8 plus 20. So the answer is 84. Okay, so 84 meter. Okay. Alright, so that's all for me. Alright, thank you for your support. Alright, so please subscribe, like and comment so that we can continue to the other version of revision kita next time. Okay, insyaAllah akan ada lagi, akan datang sekiranya mendapat sambutan. Okay, alright, terima kasih semua yang menonton, terima kasih semua yang rajin. Okay, so siapa rajin, dialah yang dapat. Okay, thank you dan terima kasih. Semoga kita bertemu lagi. Bye.